Welcome to the Explainer. Today, we're going to break down the fundamentals of one of the most fascinating fields in AI, reinforcement learning. So let's kick things off with a pretty big question. How can we teach a machine to master something, not by feeding it a bunch of rules, but by just letting it learn from experience? How does it figure out the best moves in a game or how to control a robot, all by itself? Okay, so here's how we're going to tackle this. First, we'll look at the core problem reinforcement learning is designed to solve. Then, we'll use a super simple analogy to make it all click. After that, we'll break down the key parts, see how they all work together in a cycle, and then wrap up with the one big takeaway. All right, let's jump right in. At its heart, reinforcement learning, or RL for short, is all about teaching something, what we call an agent, to hit a goal by making a whole series of decisions over time. Think about a game of chess. You don't win with just one great move. You win by making a whole sequence of moves where the payoff for one move might not show up until way, way later. RL is built for exactly that kind of problem, connecting the things you do now to the rewards you get down the road. Okay, to make this whole thing really intuitive, let's use an analogy that I think we can all get behind. Teaching a dog to fetch a stick. Seriously, this simple little interaction is the perfect model for the entire reinforcement learning framework. It's a really simple, beautiful process, right? There's a prompt from you, an action from the dog, and then your feedback. This little loop is how the dog learns to connect what it does to a good outcome. So definitely keep this picture in your mind, because we're about to map all the official terms onto it. All right, so now that we've got that analogy handy, let's start introducing the formal terms that people use in reinforcement learning. But don't worry, every single one is going to tie directly back to our dog and that stick. First up is the agent. The agent is basically the main character of our story. It's the learner, the one making decisions. It's the one we're trying to teach. So in our park analogy, who's the agent? It's the dog, of course. The dog is the one looking at the world and trying to figure out, what should I do next? Next, you've got the environment. This is pretty much what it sounds like. It's the world that the agent lives in and has to deal with. It's the stage where our agent performs. It's everything that isn't the agent. So for our dog, the environment is everything else. It's the park, the grass, the stick, and yep, even you, the trainer. It's the whole situation the agent has to work within. Okay, now let's talk about the state. A state is just a specific situation the agent finds itself in. The best way to think about it is like a single snapshot of the environment, capturing everything important at one exact moment. For example, one state could be the dog is sitting at your feet and the stick is 20 feet away. A moment later, the state has changed. The dog is now halfway to the stick. Every unique snapshot of the world is a brand new state. So from any given state, our agent needs to do something. And that right there is an action. An action is just any of the possible moves the agent can decide to make. Our dog has a whole menu of possible actions, right? It can run, sit, bark at a squirrel, or it could run and pick up the stick. The entire goal of this whole process is for the agent to learn which of these actions is the best one to take. Now, this next piece is absolutely 100% key to this whole thing. It's the reward. The reward is the feedback from the environment. It's a simple signal, usually just a number, that tells the agent if it's doing a good job or a bad job. So when the dog brings the stick back, you give it a treat. Bam! That's a big positive reward. That tells the dog, yes, do that again. But if the dog just sits there, no treat. That's also a kind of feedback, right? It tells the dog, that action didn't really get me anywhere. And finally, that brings us to the policy. And in a lot of ways, building this policy is what this is all about. The policy is the agent's strategy. You can even think of it as its brain. It's the logic the agent uses to pick an action when it's in a particular state. So the whole point of all this training is to help our dog develop a good policy. After a while, its policy becomes a simple rule inside its head. If I see the stick over there, the best thing I can do is run and get it because that's what leads to a treat. So we have all these building blocks now: the agent, the environment, state, action, reward, and policy. How do they actually come together to create a learning process? Well, they all work together in a continuous feedback loop. And this is the cycle right here. The agent sees the world, that's the state. It uses its brain, its policy, to pick a move, that's the action. The world reacts, it gives back some feedback, a reward, and a new situation, a new state. Then, and this is the magic part, the agent uses that reward to update its brain, to make its policy just a little bit smarter for the next round. This loop just keeps repeating, thousands, even millions of times, until that policy gets incredibly good at picking the actions that get the most reward.
So after all of that, if you're going to walk away with just one single idea that sums this all up, what should it be?
Here it is. It's all about an agent figuring out the best strategy through pure trial and error. Its one and only goal is to maximize not just the next reward, but the total amount of reward it can rack up over time. It's basically learning how to play the long game. This simple but really powerful idea is behind some of the most mind-blowing breakthroughs in AI, from beating the world's best players at complex games to controlling robotic arms with incredible precision. Which leaves us with one final thought, right? If a machine can learn to master a task just by doing it, what are the limits to what it could eventually learn to do?